Okay, let's talk about problem 7. We're going to start with going over the example here, right? So in the example, a football player punts the ball, right? Punts the ball at an angle of 52 degrees, right? So that's 52 degrees right there. So punts it at an angle of 52 degrees. There's nothing about the wind that's going to have any effect, and it's going to travel, right? This ball is going to travel horizontally a total of 63 meters, right? And that's what we know about the ball so far. So the first question, how high does the ball go, right? So we have to go through several pieces in this. First, the vertical component of velocity, right? This is our equation for the vertical component of velocity. Vy equals the acceleration in y times time plus the initial velocity in y. Well, we don't quite know the initial velocity. It would be an easier problem if we knew the initial velocity. We don't quite know it. And the initial velocity in y, right? Let me redraw this, right? If that is our initial velocity v naught, and it's taking off at 52 degrees, right? Then the initial velocity in y is this component, right? And so from the Pythagorean theorem and everything else, it's the same as this piece right over here, right? The same as that piece right over there. So the initial velocity in y is just going to be v naught sine of theta, where theta is at 52 degrees. And that's the initial velocity because v naught, this piece is the hypotenuse. 52 degrees is this angle here. The y component is the opposite side, so opposite, the opposite side is the hypotenuse times the sine. All right. The other thing we know, and it's right here in the problem, is that the acceleration in y, right, is simply the acceleration of gravity in the negative direction because the acceleration of gravity is down. If the acceleration of gravity was up, we'd all be flying off to the moon, and hopefully we'd hit. Otherwise, we'd just keep on going. Right. So acceleration of gravity is down, so that gives it the minus sign. All right. So we know everything in this equation except for time and the velocity in y. But here's what we're after, right? All right. So we know v naught y, right? It's just the v naught times, well, we don't know v naught, right? It's v naught times the sine of 52 degrees. We know ay is minus 9.8 meters per second squared. Okay, that's the vertical component. We filled in what we know, right? Horizontal, when we look at the position horizontally, we've got x equals 1/2 at squared plus v naught xt plus x naught, right? That is a horizontal position. And what do we know about this, right? Well, we know the acceleration is 0, and we know the initial starting point is 0. And just like the y component was v naught sine of theta, the x component is v naught cosine of theta, right? And that theta again is 52 degrees, and we don't know v naught yet, right? All right. So we have an equation for the position in this direction. We have an equation for the velocity in that direction. And we're going to start putting these two pieces together to kind of help us out here. All right. Now part of it is when the ball reaches the top, right? When it reaches the top of its arc. So the ball goes up and comes back down, right? When it reaches right here at the top, what's its velocity in y? What's its vertical velocity at that point? Well, its vertical velocity at that point is 0. All right? And that happens, this problem is symmetric, that happens at the halfway point. So the x position of that event, when the y velocity goes to 0, is 1/2 of this total distance. All right? Okay. So we're going to use these two equations. Equation 1 up here, right? Putting in what we know. Equation 2, again, putting in what we know, right? We're going to use those two equations. And then we're going to use this third equation, y equals 1/2 yt squared, ayt squared plus v naught yt plus y naught. Well, y naught is 0, right? We're going to use this equation along with the other two to try and figure out how far the ball is going. All right, so let me pop up a word here real quick and write down where that puts us, right? Okay. So we have Vy, all right, and we're doing this, remember, we're doing Vy at the top where Vy is 0 equals minus 9.8 meters per second squared, right, times t top squared, right, oh, not squared, t top, right, plus v naught y, which is v naught sine of, what was it, 56 degrees, right? So, and I'm going to erase this bit right here, the Vy. So this is our first equation, all right? And go back over to the problem here, all right? This is our first equation. We've got minus 9.8. We got t at the top. We got v naught y. And Vy, when we reach the top, is simply 0, right? That's when it comes to a stop in the vertical direction and begins to head back down the other way. Okay, so on how, let me check the, what was that angle again? The angle is 52 degrees. All right, so I'm going to change this. If you're wondering why that magically changed to 56, it's because my memory's not good enough. It's 52 degrees. Now, it goes 63 meters horizontally, right? 63 meters horizontally, and we worked out down here that when the ball reaches the top, we've gone halfway. So we've gone 31.5 meters horizontally when the ball reaches the top. So we go back over here, and we have, all right, we have 31.5 meters, that's our x position, right, equals. Now, back over here, we had our acceleration in x is 0. X naught is 0. The only thing that's left is v naught cosine of 52 degrees times t at the top. All right? So let's go back and let's stick that in. V naught cosine of 52 degrees, all right, times t at the top. Okay. So you're wondering, where does this put us, right? Well, we can actually at this point figure out what t at the top is or what v naught is based on these two equations, but let's press forward and look at right, because we've got, let's take this one, let's take the second one, right? I'm going to take this second equation and I'm just going to solve it for t at the top. Top is going to be 31.5 meters, right, divided by v naught cosine of 52 degrees. Right? That's t at the top. If we take this and substitute it, right? Let me get here, and we're going to take this. We're going to take this and substitute it in right up there, right, for t at the top. Then we have an equation that's going to give us what v naught is. It's going to end up being a v naught squared when you do everything, to put everything in together, but it's going to give us what v naught is, right? We're going to have that. And once we know what v naught is, well, the only thing we don't know down here is v naught, right? Once we use this equation by substituting in for t top into the top equation, and we get v naught, we come back down here with that. We stick it in, and we get t top, right? And then the last piece, pretty straightforward, right? Last piece is, all right, now that we have t top, right, and where we have t, the time it reaches the top, we actually have our initial velocity, so we know what v naught sine theta is, which is v naught y, right? So now after doing all of that, we know the acceleration of gravity, right? We know the time that reaches the top. We know the initial y velocity because we now know v naught. We know that is 0, so we're not going to worry about that, right? We know all of that. And so now it's easy. You just take all of that stuff you found and you plug it into the equation and you get the answer to the question of how high does the ball go. Okay, that's it for looking at question 7.